Right. We might make a start then. I think there's still some people coming in, but get all the preamble sort of stuff out the way. So, hi everyone. Thank you for coming tonight. My name's Emily, and I'm going to be your host for tonight's panel on machine learning for archaeologists. Just to go over some quick Zoom rules before we get started, maybe. Yes. So by attending today, you agree to follow CAA International's Code of Behaviour, which will be posted in the chat. But the basics are, please mute yourself, turn your camera off, except for our panelists, and please be respectful to our panelists and to each other. Also, so everyone is aware, the first part of this panel tonight, which is the structured Q&A with our panelists, is going to be recorded. We'll also be uploading it to our CAA Australasia YouTube channel in case you're keen to watch it again afterwards or share with friends, family and colleagues who might be interested. I'd like to open our event by acknowledging the traditional owners of the different lands on which each of us meet. I recognise that I'm hosting this panel from the country of the Wurundjeri Woiwurrung people of the Kulin Nation. I also recognise the traditional owners of the countries from where each of you are listening, and I'd like to pay my respects to elders past, present and emerging, and extend that respect to all First Nations people listening here today. Before we get started with our panel, I'd like to make a few small announcements, but firstly, I'll quickly introduce who we are. So CAA Australasia are the regional branch for CAA International, where CAA stands for Computer Applications and Quantitative Methods in Archaeology. We have members across Australia, Aotearoa New Zealand, Asia and the Pacific, as well as a few even further afield. And we hold a number of events throughout the year with a focus on digital aspects of archaeology and cultural heritage. If you're keen to stay abreast of updates of in the digital archaeology world or attend more of our events, it's completely free to become a member of CAA Australasia. You can jump on our website using the QR code on the screen. You can also follow us on social media. So we have our Facebook, Blue Sky, LinkedIn, Discord and YouTube channel, details up on the current slide. Simon will also post all that information in the chat. We also want to put a couple of upcoming events on your radar. So next month, to coincide with National Archaeology Week, our own Michael Rampey will be hosting an online workshop on Gaussian splatting, which is a newer technique taking over the 3D modelling world. On the 1st of August, that will be UNESCO's first International Day for Underwater Cultural Heritage. To celebrate that, we'll be running a panel in collaboration with the Australasian Institute of Maritime Archaeology. And then in early October, we're very excited to announce that we'll be hosting our 4th online conference. So more details for each of these events will be forthcoming in our newsletter and on our socials. So make sure you sign up or give us a follow to keep up to date. So back to our current event. Tonight, we'll be talking a lot about machine learning in archaeology. But what is machine learning? At the moment, most of what we hear about is all about generative AI, so ChatGPT, Claude, Copilot, where tailored text and images can be produced in a very short amount of time based on input prompts. But machine learning is far broader than this, encompassing the development of algorithms that can learn from patterns of training data and then make accurate predictions when new data is presented to it. In archaeology, we're seeing this applied to a range of different areas, including but certainly not limited to the automatic detection of certain features in geospatial imagery like LiDAR, different forms of text analysis, such as predicting the missing parts of fragmentary texts, and classification of different features and objects like ceramics or bone taphonomies. And I'm sure we'll hear about some others tonight. So we can train models to detect certain features or patterns based on training data, and this can greatly assist with the way we go about our research and work. But machine learning also brings with it plenty of issues and limitations, which we can discuss more with our panelists. To introduce the format for this evening, our 4 panelists will kick off proceedings with a short introduction to themselves and their work. We'll then move on to a structured Q&A session where I'll be quizzing the panelists on their experiences with machine learning in the archaeology and heritage space, and their thoughts on both the possibilities it offers as well as its limitations. After this, we'll be opening up the floor so that you guys can have a chance to ask the panelists any questions you may have. Your questions can be posted in the chat. This can be any time throughout the panel. You don't have to wait until the end. or you can raise your hand when we get to the open Q&A part, and one of the moderators will direct you to unmute when it's your turn. So it's my pleasure to now introduce our 4 panelists for tonight. I'll get you guys to turn on your cameras if you haven't already. So tuning in from Aotearoa, New Zealand, we have Dr. Josh Emmitt, an archaeologist and the current curator of archaeology at the Auckland Museum, Tāmaki, Paenga, Hira. We have Dr. Jawed Karlesa joining us from South Australia, where he lectures in archaeological science at Flinders University and specialises in digital methods in archaeological research. Bringing more of an industry perspective, we have Dr. Christopher Bateman, who is Head of Artificial Intelligence at Intranel Consulting Services, a software company based out of Christchurch. And to round things out, we're joined by Dr. Robert Hout, who works both as a senior lecturer in computer science at SAE University College, as well as an adjunct senior research fellow in computational archaeology at the Australian Research Centre for Human Evolution at Griffith University in Queensland. So I'll now hand over to each of them to introduce a little bit more about who they are and what they do before the questions begin. Jared, I'll start with you, if that's all right. And you said you don't have any slides to share, so take it away.
Hi. So thank you very much for having me along for this panel. It's really exciting always to talk about machine learning. I'm here on Kaurna country, so in South Australia. So I'd like to acknowledge traditional owners of Kaurna country. I'm a lecturer at Flinders University. I think I'm a fairly, relative to the broad spectrum of things, a early adopter of machine learning in archaeology, at least in my experience of archaeology. It's something I started looking at in my PhD and have been applying in a broad sense ever since. My uses of machine learning have been pretty broad, really. They've mostly been focused on stylistic analysis. So rather than classifying things into categories that we've already preconceived or training things to tell us what we want them to tell us, taking a step back and sort of training things to recognize things, to order things on their own, and then see if we can make sense from the way that ordering is done, looking at activation space analysis and looking at dimensionality reduction techniques within the learnt space to try and see if we can reduce the bias about some of the categories of classification that we have for things. This has been applied to rock art classification and stylistic analysis. I've been applying it recently within a large ceramics assemblage from shipwreck materials to try and understand what groupings we might have there, whether we've got ceramics that are associated with an individual shipwreck that might be from a similar batch made by similar artists, whether we can see groupings that we didn't otherwise detect, things like this. But I've been really incorporating all sorts of aspects of machine learning into daily workflows, from these really analytical applications through to just really quality of life things like automatically masking all my images to the ceramics and removing the backgrounds so I can automate photogrammetry workflows and things like this. So feature detection in landscape archaeology as well. That's sort of what I've been doing with machine learning. I'm a landscape archaeologist, so I do lots of sort of different general geomatics and geophysics and things like that as well, which all have a little bit of ML embedded in them from time to time.
Me myself. Very cool. Thank you so much, Jared. I think let's move on to Robert next. And for this, I need to unshare my screen. So everyone just bear with me. Oh, have I done it already? No. Stop sharing.
And, I don't know if you can see my screen.
Not yet. Hang on. There we go. Ready to go.
All right. So thank you, Chair. I'd like to acknowledge the Kumameri people from whose country I'm speaking to you from today. And rather than focusing on a single project, I want to share how 20 years of working in digital archaeology has changed how I think about information. And I titled this Towards Systems Thinking in Digital Archaeology, because I believe we're at a crossroad now, a crossroad in how AI makes us think, about knowledge itself. Let me take you on a quick journey, not through 20 years, but through a mind shift in those 20 years. I started my work in symbolic AI, looking at ontology, semantic web, structured knowledge. And the idea back then was simple. If we structure data well enough, machines can help us understand it. Inspired by Tim Berners-Lee's vision of the semantic web and linked open data, I became really interested in the question, what if machines could actually understand archaeological data? But the reality was really, really messy back then. In 2009, Tim Berners-Lee talked about data silos, incompatible data formats, fragmented knowledge. And this was all not limited by theory, but it was limited by infrastructure and standardization. So different problems from today. That led me into building structured models using frameworks like the CDOCS from research in rock art. We made data sets machine readable, interoperable, scalable, and the work was used in anything from literature synthesis to connecting data sets and metadata extraction. And then came neural networks, and everything really changed, not because they replaced symbolic systems, but because they think differently. Neural networks learn patterns, not rules, like symbolic AI, and this is really often misunderstood. So now we're in a world where we have both neural networks and symbolic systems, and they both find applications. Take, for example, language and cognition work by Lara Boroditsky. She gives tangible examples on how our languages shape how we think. Now imagine training an AI on First Nations languages. Abundant Intelligence is such a project that looks into developing AI based on indigenous knowledge systems, imagining what we can learn from this. This is really interesting because this is where neural networks, ontology, as well as cultural knowledge really intersect. That should be really interesting for archaeologists and anthropologists. But let's look at work in computer vision as well. Some of my past engagement included work on AI for rock art classification and motif identification, looking at, for example, challenges of superimpositions in artwork, or a more experimental project here on the right. We asked if AI can determine the sex, for example, of finger fluting artists based on only the images or VR data that we collected on finger flutings. These results find applications in fields all the way from criminology, forensics, and cognitive science to archaeology. So where are we now? Well, three directions have become evident. Just as Berners-Lee said in 2009, we still need more data to make things more accurate. We see trends in multimodal AI. We can also see convergence with creative technologies in AI. But alongside this, we have the impact on society and people that shouldn't be dismissed, like ethics, governance, data sovereignty. These are no longer side conversations. They're central to any debate that we have in AI. So how do we move forward? For me, the answer is in systems thinking. We need to break down silos. We need to connect disciplines. We need to share knowledge across domains. This is all possible because of AI now. Before it was extremely difficult. But with that come responsibilities. We need to also balance human, environmental, and economic impact. And most of our projects have some of that element in there. It needs to be together, not separately. One example that I had the pleasure of working on was digitizing the deep past at Griffith University that brought all of this together. It combines Indigenous education, addressing digital divide and STEM education outcomes in Indigenous communities, cultural heritage preservation, and digital literacy, as well as advancing AI. Through a mobile citizen science app, Indigenous youth with local cultural heritage and rock art management, it assisted them essentially by identifying motifs in learning about the latest AI technology, improving their digital literacy and their STEM skills. And the result was that we didn't just have better data for the researchers, but we actually had stronger cultural engagement through digital tools. We had improved STEM outcomes in digital literacy, as well as community-led knowledge creation. So to close this 5 minutes, I might be slightly over. Where did this lead me after 20 years? Well, for me, it's not just about symbolic versus neural networks or LLMs versus computer vision. It's about connections. it's about systems thinking that allows us to see how knowledge links, how disciplines intersect, how knowledge and technology can amplify that understanding. AI's real power is not in automation, but in revealing these relationships. This is what I learned from 20 years in digital archaeology, no longer siloed, but meaningful, interdisciplinary, and interconnected, contributing to knowledge through a non-zero approach where we move forward together. So that's pretty much me in a nutshell. Thank you very much.
Thank you so much, Robert. I'll hand over to Christopher now if you'd like to share your screen.
A moment to share my slides. You can hear me?
Yes, we can.
That one. Full screen. You can all see that?
Yep, we're good to go.
Cool. Hi, everyone. I'm Christopher. I've been working in tech for about 15 years. I started off in academia and slowly migrated towards the more industrial side, where I do a lot of contract work to especially ag tech organizations and do a bit of work in medtech and environmental work. Today, so I'm not really an archaeologist, but I do have a project of interest, which I'm going to be talking about. So I thought today might be interesting for me to bring a bit of perspective on how you actually conduct developing ML solutions. That has actually been evolving over the last 4 years, and this is something which started just a little bit before the ChatGPT takeoff. There was a big boom of you might have seen the early diffusion models or image generation. That sort of is a big rage of that just before ChatGPT took off. What was happening there was a big boom of training models with large data sets, and you didn't just get things like ChatGPT and the image generation, the curriculum models. There was a whole lot of other foundation models that were being built for general purpose machine vision use. Dino V2 and Dino models for general purpose features representations for analyzing image data. Your clip, your incorporating basic natural language for doing queries, open world detection models. All these things were kind of converging at the same time, and that's started to give us some interesting tooling for, well, one, making how you approach, especially the data side of machine learning, which is one of the most expensive parts, start to make that cheaper, more tractable, give you more shortcuts, more avenues to explore for making solutions, say non-traditional routes. So an example project that we had, so this here was our first project where we used a language model to solve a vision problem for a client. So we were approached by a small environmental consultancy at E3 Scientific, who are working with Environment Southland to find sheep dipping sites, historic sheep dipping sites in Southland. So if you don't know, sheep dipping was a practice that was performed all over the world, but in New Zealand it was mandatory in the middle of the 1900s for a number of decades, where they would walk livestock, in this case sheep, through troughs of horrible chemicals to kill pests and parasites in their pelts, which questionable what that would have done to the livestock, but what it did to the land. These are forever chemicals, things like arsenic, are still in the soil today, and are still at levels which are of highly concerning. So here's an example. So here's a sheep dipping site from old historic era of imagery from 1958. Today, you cannot tell anything was there. And there's, to put a bit of a perspective on the scale of this problem, there's 50,000 of these sites estimated in New Zealand. We only know where 2% of them are. And we're having a massive increase in urban sprawl. So it's it's a ticking time bomb. Like you don't want, for example, a preschool or a kids playground or a community garden to be built on these sites. So if going back 4 years ago, if I was given this problem as a machine learning problem, I would say, no, it is not solvable. But again, everything was kind of convolving like at the right things at the right time. We were given 30 registered locations, a whole lot of aerial imagery that was very blurry. The sites were hard to see. We could only find about 18 of them in the data. So not enough data to train a model at all. And so we had to try and work out a low data solution. And luckily, we had, this was at the same time that the first vision-capable component of ChatGPT came out, where you could load an image and ask it questions about the image, and it kind of got it right. So we had this crazy idea of, why don't we use some vision foundation models to do some similarity matching to kind of filter out a lot of the like the empty fields and all of that sort of data, and then so filter out 99.99% of the data, and then use prompt engineering to get ChatGPT to be our classifier for us. And our trial, we looked at 7% of Southland, and we managed to find 350 odd sites of concern. Again, the imagery was very poor quality. Only about 128 of those sites we were actually able to have clear enough imagery to have very clear imagery of the structure itself. The remainder of sites were areas that our expert reviewer of the data that we of sites that we generated was concerned that this was likely a place that sheep dipping would occur. So we need to go test for soil anyway. So you can see there a map of all the sites that we found, very clustered. And if we scale that up, it proportionally, it is in the ballpark of what was expected if we were to scale this up for the entirety of Southland. So a bit of a look of our hodgepodge of a machine learning algorithm. No model training was done, but this is still would be considered machine learning because we're still using AI in a sense. So we used a pre-trained model to extract the features of general purpose features of the data, then similarity mapping to our small handful of images that we or sites that we knew about, and then we get out patches like this, and you can see there. I'm not sure if you can see my mouse as a pointer. We got here. That's a little of the bottom left tile there. There's a little circular thing next to the sheep yard just above the house. There's probably the best picture of a sheep that you'll get out of this imagery. Yep, put it through a target classification, and yeah, simple as that. And you're not guaranteed. I think we got about a 70% yield of sites out of ones that we got, and you're not actually expected. Like you don't actually expect this to be a perfect classifier, but if you were to approach us from a classical machine learning perspective, you'd get, say, an army of interns or students to go through, trudge through the data, try and find these sites, make a data set, train a classifier. And that process itself is actually very expensive, even using cheap labor. But here, a hodgepodge of pre-trained systems cobbled together, you can do all that very quickly, and then you could scale up and have a sizable data set to actually put through a traditional machine learning process if you had to. So sorry, I tend to ramble on a little bit. Back to my original point, the way we approach machine learning now is evolving quite a lot. Here are 4 hot takes of how things have changed for me over the last 4 years. Everything we do now, we do AI rubber ducking. So any major decisions around architectural changes, discussing technical details, loss functions, use an AI to brainstorm. You're not asking it to do it for you. You ask it to sense check your ideas, and if you know a general idea of what you need to do, it can help you find the terms that you need to search for what you need. Coding agents, since December last year, or end of November, effectively December, release of Opus 4.5 from Anthropic, coding agents can pretty much do 99.9% of your coding now. I'm not saying sort of vibe code your application, but if you can describe what you want coding, the code that you need, then in detail, then it can code for you for the majority of it. A couple of weeks ago, auto research. It's a way you can trick your coding agent into doing hyperparameter experiments for you, and it will autonomously decide what's the next best hyperparameter thing to do for you. You can let it run it overnight. That's something that we've started doing, and making use of all the general purpose pre-trained models that you can. If you're not aware, Hugging Face is a repository of hundreds of thousands of open source models for everything. That's your starting point for building any machine learning system these days. Thank you. If you want to connect with me on LinkedIn, QR code's up there for probably 5-10 seconds before my slides get kicked off.
Amazing. Thank you, Christopher. We can also share these details as well after the presentation. So amazing. And lastly, I will hand over to Josh. Do you have slides to share as well, Josh? Or
no, I didn't get that far.
All good.
So kia ora everyone, my name is Josh Emmitt. I'm the Curator of Archaeology at Auckland Museum, and I'm also the current chair of CAA International. So forgive me, I just got back from the conference a few days ago and I'm still fighting the jet lag up a little bit. My experience with machine learning really began about 15 years ago. We were working on projects to develop data management systems for our field recording. And I was talking to computer scientists we were working with, and I said, hey, could we automatically get our images tagged here? And he's like, give me thousands of dollars and 3 years and we might be able to do it. People have been trying to do this. And then a couple of years later, he's like, oh, by the way, we can do that really easily now. Find all the birds in an image or something. I'm like, oh, great. Okay, I don't need it now, but, thank you. And then I kind of just had it as a thing that, I knew we could do in the back burner. And it wasn't until a number of years later, really what we discovered is that as archaeologists, we can't move fast enough. We're recording a lot of data in the field. We're recording piece provenance information. We're taking images of artifacts. We are constantly, as a discipline, we're constantly excavating, whether it's in the commercial realm or in the academic realm. And we're in the likes of New Zealand, we're working against sea level rise and the coastal erosion, where sites are constantly being eroded that are having to be mitigated, but we're just not getting to look at the actual things. So there are storerooms, such as the Auckland Museum and other places, of material that hasn't been looked at. So the challenge is we need to move faster, and we just don't have enough people. And the other thing is consistency. If you put 10 people looking at stone artifacts in a room, you're probably going to get a few different answers of the parameters, just because there's differences in what people see and record. So one of the things we did was, can we use machine learning to standardize this? And so this was about the time of COVID, pre-COVID, somewhere around there. We started machine learning stone artifacts. And basically, could you tell a stone artifact from a rock? We were going to go down into flake cores tools, but we didn't do that, because then we quickly got into the thing of what is a flake core or a tool, and that definition was a 6-month rabbit hole we just couldn't find an answer to, really. So just rocks versus stone artifacts, and we got a model that really could differentiate the two. And we used data from New Zealand, Australia, and Egypt, where we'd been taking images of every 10th artifact that we surveyed in since the late 90s, back on some of the first digital cameras, way before when I was not even in high school yet. But we didn't know what to do with the data, and we were able to pull all this legacy data forward for a new purpose, which was really cool. And so we did that study, and when we went to publish it in PLOS One, you said you have to publish the data, and I'm like, that's fine. We had an agreement with the iwi in New Zealand, Aotearoa, where some of the data was from, that we could publish the data, and as long it wasn't connected to any, say, physical locations, it was just kind of the images themselves. And same with our Australian and Egyptian data. So that came out, and that was all well and good. And then I got a different job, and I kind of lost a little bit of track on it. We started doing another project for building a photogrammetry rig, which the idea that we could machine learn stone artifact analysis from that, and we're still working on that project at the moment. But more recently, my attention's been more turned to the ethics and the data sovereignty issues of machine learning, and particularly when we expand machine learning into AI. So when we've got something that's trying to not think, but interpret those results, as opposed to just, say, a tool that's giving us an answer that we're asking for. And I think the thing is that with these data sets we're putting out there, once they're out of the bottle, we can't really pull them back in. And it's really trying to make sure that people understand that is a real challenge. And especially with traditional owners and iwi and other indigenous people around the world, it's really like, we've got these great ambitions as archaeologists, and it can help us, but in helping us, what harm might we be causing, deliberately or otherwise? And I think that this is something that I've really been putting a lot of attention into more recently, just about how we can work with iwi, and because from New Zealand, how we work with iwi with our data collection, and so that we can create proper standards for how that data may be used down the line. And more often than not, we see the answer is people put them in these big repositories and they tag it as Indigenous data and just pat themselves on the back. And it's like, that's not quite good enough, actually. Like, these models or these data can be used for almost anything without permission. And it's a bit of an extreme example, but if we were having some of these photos of artifacts somehow used in training war robots, would people be happy with that? And so it's a real, there's a lot of quandaries that we're trying to think about, and there's no clean answers, unfortunately. And that's really what I'm just kind of working on in the background.
Well, thank you so much for that, Josh, and everyone for those introductions. So I'm going to just painfully share my screen again. Which one is the right one? Excellent. So we can get started with our questions. If everyone can see the screen, and I will tick that over. All right, so for my first question tonight, so I think we've heard a lot now about how the widespread adoption of machine learning, particularly with recent advances in things like generative AI, this is being increasingly heralded as a watershed moment, entirely transforming the way we work. So I wanted to ask you guys whether you think this holds true for archaeology and heritage, or are the effects of machine learning more subtle or contained in our field at the moment? And yeah, feel free to unmute yourselves, jump in. If anyone has a thought.
You go first, Josh.
Oh, no, you go. Please, you go first.
I think from a sort of to a more of a wider kind of, or more general kind of perspective, the current changes like that we're seeing in AI is going to affect every part of our lives, and archaeology, heritage, and all that. That's going to be no exception. I think one of the things I think Josh mentioned it is I think the biggest I suppose the biggest concern here is the speed of the changes, and the speed of which it allows us to do things, which I think there's a lot of risk involved in what's happening. So if you're able to process data quickly and say, make inferences about it quickly. You're able to ask your AI chatbot, your AI agent assistant to analyze data for you, make reports. Then time and the speed of which it happens. Previously, that used to be when it was just humans in that loop. That was a bit of a handbrake, and it gives enough time to sort of sense check things. And I think we're sort of skating on thin ice a little bit in terms of a lot of things are going to get through which are going to be undesirable, and we need to be very cautious with how we approach integrating these things. We need to integrate them, because if we don't, we'll be left behind, and there's a level of redundancy in that. I think there's a high degree of risk which we need to be aware of and juggling in these areas.
Great, thank you. I might just jump to you, Robert, actually, and then Josh, we can come back to you with some final thoughts.
Feel free to jump in first as well. I can wait if you want to go first. Well, yeah, I just wanted to second. Thank you, Christopher. I just wanted to second what you said. And Edward Wilson, a biologist, he had that phrase, right, where he said we have Palaeolithic emotions, medieval institutions, and godlike technology, and that's what it feels like. Exactly, that's where we are today, and we can't keep up. Like human brains are not wired to that just yet. Maybe we're changing in the future, right? Who knows? But at the moment, it's the speed. I second that. It's the speed that is really difficult, and it's dangerous as well. And I think it doesn't just change what we produce, but it also changes our culture. Our expectations in our workplace has changed. And we come, I think, or what I've seen sort of across the board as well, is that people stop focusing on some things that might be important, like the ethics issue, because of the pace, and we start missing information that should be in there. So I think that was just my 2 cents on seconding what Christopher said. I think this is also a cultural issue then within the field.
Great. And Josh?
Yeah, I think that basically it's already changing things whether we want it to or not. And it's as it's been commented, it's going fast. I always think of Jurassic Park when Sam Neill goes, we're all running to catch up, and it really does feel like that sometimes. We're constantly trying to, put this genie back in the bottle a little bit just so we can try and understand it. There are computer scientists out there that can tell us all about how it's working in the background, but in the reality, we think it's working in the background, but when we really get down to it, do many of us understand fully the methods that we're using, like down to the minutiae, or do we leave that to experts and trust that we're being told the right information about how it works? And I mean, I just saw in the news the other day, University in Manila has developed a ArchaeoBot, they're calling it, which is going to do automatic field work or some kind of automatic survey. And we're already kind of doing things like that with drones, and even remote sensing is somewhat doing that kind of work. So these changes are already happening, and it's just kind of making the processes faster. But as Robert commented, ethics is the first thing to go usually. People get all excited, and then the next thing is, oh, well, we can deal with that later. And it's kind of like we need to deal with it before we even start thinking about using it. And so I think, it's going to be transformative, and it already is transformative for, what we're doing as archaeologists and in heritage. But we kind of need to somehow hit the brakes and, really make sure we've got the seatbelt engaged.
Right, and I think we'll return to probably some of these more problems and the ethical questions around it towards the end of the panel as well. Jared, did you have anything you wanted to add before we move on to the next question?
I'll just a brief bit of agreement with what others are saying. I really think that my initial response is, it's changing the way I'm doing a lot of things in archaeology, but it's not really changing the core of what archaeology is. It's not changing the theory or the interpretation. It's just changing some of the eases and the efficiencies. But I think one of the biggest problems and the risks and the ethical risks that everybody's talking about goes hand in hand with this. There's a massive sort of broad scale aversion to AI, and I understand and I support it in many ways to say, oh, don't use AI. It's really dangerous. It's really problematic. But AI is going to continue one way or the other. So I think that increasing our understanding of what it's doing, how it's doing it, and our understanding of the methods, not just individually, but across our discipline, is going to help people make the safer choices rather than just trying to hold back the floodgates and say, no, 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 don't do it ever. It just start to understand, like we should be really trying to understand sort of what Josh said, is understand the methods we're using. People often confuse AI as this broad term with a specific model, ChatGPT. Oh, you don't want to give your data to big companies, but that's not usually what archaeologists are. They're running some local Python script on their own machine. It's not that at all, right? So understanding is going to help people tailor this with the ethical considerations so we can make safer choices from the ground up. But we need to talk about it more, not less. Yeah.
Amazing. Maybe just as a follow-up to that question as well. So I guess we have raised sort of the ethical considerations now. What are some practical things that you guys are seeing workplaces and universities doing to sort of bring this about, or are we not doing it at all?
Can I start with one practical comment that's not really universities, but it's a publication. It's just building on exactly. I had the exact experience that Josh, that you talked about with Plus One as well. Specifically, the first machine learning paper I wrote, I wanted to go with them. They reviewed it, they accepted it, and then they said all of the images and all the data has to be Creative Commons license, and this included rock art depictions of cultural material, and it was an immediately we can't do that. And there was just no leeway. It's like, sorry, that's science. If you don't make this data available, it's not science. It's, we can't verify, I guess people can't replicate this learning. But within a cultural heritage application, we need to think about how we can do this in a culturally appropriate way to mitigate those risks. And so, yeah, it's moving really fast. So we had to shift journals for that paper. Australian Archaeology, which is a dedicated archaeology journal, was much better at understanding that we can't make this data set available and is still willing to publish. So I think that's one of the first things we need to think about is, the actual procedure broadly and how that we're disseminating this information. And we're sort of following lead from big data, from medical advances, from machine learning, dedicated machine learning research, which is obviously going to be sharing these data sets, and that's a big profit margin for them. But we need to find a way that we can do it within archaeology that's going to work for communities, traditional owners, for us as archaeologists, which doesn't really exist right now, other than individually bespoke negotiated arrangements, I would say.
Robin?
Thanks, Jared. And I second everything that you just said. Obviously, that's a huge problem for, I think a lot of us also, not just in the panel, but in this entire group, the publication issue around, the data sets. But I just wanted to add as well, there's also an element within, the bigger ethics picture where we have a responsibility to train, for example, First Nations people that we work with. What do they know about data sovereignty? And because there's a digital divide, right? There's this huge gap, and by us using technology, we actually drive that divide even further. So I think also, as Jared said, we really need to rethink how the system works, and it's not a technical problem; it's a problem on how we structure this within the society and within our field through policies and guidance.
Who takes responsibility for that? That's probably what I'm interested in, and that's probably a bigger question than what we have time to cover. But yeah, if we can maybe return to that towards the end of the panel as well. I'm going to move on to our second question, which is maybe slightly less heavy. What are the most exciting avenues that have opened up for each of you in archaeology or other adjacent work by machine learning? So what's been the coolest things that you guys have been able to do?
I can start this one. For me, it's been, as I said before, it's the ability to maybe start thinking about catching up We've got collections sitting in storerooms which are going back to the 60s, haven't been looked at. There are some, don't think there are any older that I know of, but they just haven't been a priority for people. People have been so preoccupied with excavating and answering immediate questions with brief analyses, and then all the other, what they consider debitage or unimportant, that just become part of these legacy collections haven't been looked at. And when we actually go back and look at them, we can usually rewrite most of the conclusions people have come up with because they only focused on a small subset. And because part of that reason was that they had to subsample because that's all the time they had. Whereas now, with the right kind of tools, we don't have to subsample anymore. We can look at everything and get a fuller picture from our already subsampled excavation context. So for me, that's the exciting thing, is that it's really opening up our ability to kind of, look at more data, look at kind of everything we're excavating, which I think is the responsible thing to do. I see some people bucking against, in-field recording techniques or the speed at which they're doing, and then they also say, oh no, we can just use that for the post-excavation stuff. And it's like, yeah, okay, but what you're really saying is that you want to just go out there and dig to your heart's content and then have the machines do all the work for you, or the stuff that really needs, some human thought as well. So, yeah, I think it's the exciting thing is that it's going to let us, hopefully, if it's done right, it will let us kind of do what we should be doing as archaeologists, we should have been doing all along, which is look at everything that we're pulling out of the ground or off the ground.
Any other thoughts from our other panelists? If not, we can move on to question 3. Or can we? All right. So my third question is machine learning something that everyone should be using in their work and research? Or does it have some very specific applications in archaeology? Like, how far do we want to let this run, I suppose? And are there things that it just shouldn't be used for at all? I will just pick someone as well. Christopher?
I can start while people are thinking. Jared, you have your hand, please.
No, you go.
I just think the one thing I was going to say is that if people want to use it, there's always a function that they could use it for. But I think the main thing here is that as long as that use is informed, the data they're using it with, the people whose data they're using, as long as that is all done with consent and understanding and agreements, then if they want to, go for it. But without those other things, I think it's kind of wrong to be using it at all. Yeah.
That's really very close to what I was going to suggest. I think that there's applications in everything. You can always find efficiencies or even achieve things that you couldn't before in so many different avenues of machine learning. But you do have to pair that with understanding what's involved in that. And I think that this comes with learning more, everybody understanding more about the foundational concepts of what's going on in this broad AI, machine learning, all of these things will increase the number of applications that they see to their everyday activities in archaeology, but also increase their ability to safely engage with how they're going to do that. Yeah.
Christopher or Robert, do you have anything to add to this
one? I think you kind of got two sides of machine learning coin. You've got, so if you go down your agentic AI side of things, then I think I'm always an advocate for rubber ducking, as I mentioned earlier. If you go to the other side, if you're looking at actually training models for analyzing data, there are a lot of limitations like that you need to be aware of, and there's how you set up a problem, how so say for example, if you've got your data set a certain way, and then your model certain, say, fixed for a certain size of input data, then they can make features in your data either visible to the model or invisible but based on the relative scale of your data and your model. So there's all these little pit traps that if you are going down the model training route, you need to be aware of. But again, if you're rubber ducking with an AI, it can help guide you. And I think using the rubber ducking as a I suppose as a bit of a muse for it, if you know that there are things that you don't know, you can ask AI, what is it that I may not be thinking about here? And that can help, in a sense, guide your learning on how to do the more traditional machine learning side of it. But you do need to be wary that there are lots of pitfalls that you may encounter along the way.
And Robert?
I just wanted to kind of add a slightly different problem, but it kind of is an analogy to this. I remember debates around projects that I was working on. Should we be using a MySQL database, or should we be using Access, or should we be using Excel spreadsheet? And it's a question of scale, and it's a question of where do you want to go? And sometimes Excel is the right platform for it, but sometimes it's really not. And I think it's the same with AI. You just need to kind of look at the purpose and the scale and see where you want to, where this should go. So I think that the question is actually rather complex, and it really depends on the individual projects. But AI is definitely not a solution for everything. And we all know this. We all read the papers, right, that come out of Stanford and MIT that tell us the cognitive impact on our ability to think if we use AI too much. And there's a clear decline there. And I think the same applies to researchers. We shouldn't over rely on this. But for me, it's kind of analogous to that Excel spreadsheet, versus more complex databases format.
All right, I'm going to skip over question four.
Quickly jump on that.
Yeah, sorry, please.
Robert raised a very interesting point about the cognitive decline. Is the one of the interesting things of that is it depends on how you're using AI to augment what you're doing. So if you're using AI to delegate cognitive function, then you do undergo cognitive decline. But the other side of that coin was in people who use it to assist, like sort of by using it in a way where enriches their sort of creative process, they don't undergo the same level of cognitive decline that other people would otherwise. So that's in itself a thing in terms of how we're using this, that can guide us into the sort of ways which we can use AI effectively in what we're doing. Yeah.
Thank you. Do you think that that's something that we should be explicitly guiding people in, Christopher? So I feel like people do tend to just rely on it for a lot of things, and maybe we need to have some more explicit practices about how best to use machine learning in our work.
I think it's that comes down to the question. Was it 1, 2, 3, 4, 5, 6? I think question 7 about the incorporating machine learning into university education. I think we've got numeracy, we've got literacy. I think there's a case of AI literacy in how to appropriately use AI in a way which is not self-degrading. And that is, I mean, we're learning by fire at the moment, and there's a lot of people out there who are being negatively affected by the use of AI in this context. And I mean, unfortunate, but this is how we've learned with almost every other disastrous thing in history. And I do see that in the future, there will be a necessity of an AI literacy of how you use these tools in a way which is enriching and enables you to approaching AI through a growth mindset rather than I suppose a laziness mindset. It is going to be essential.
Robert, I'll grab your thoughts on that as well.
I definitely agree with you, Christopher, that there's two sides, right? You can use it to really advance knowledge, and then you can use it sort of the wrong way. And I'm an educator as well, and this is one of the biggest challenges at the moment. How do we teach students to use AI responsibly, right? And that's a huge challenge. And that's the next generation of everyone who's here, right? Or maybe there's some students already in this panel here, or in this group as well. And there's this unfortunate thing that humans always try to preserve energy, right? So we always go for the shortcuts. And AI is so persuasive as well. So when you write something, I mean, we all know this, that all of a sudden you go, wow, this is amazing. But when you really deconstruct it, sometimes you go, oh man, there's a lot of nonsense in there. So it's very, very difficult. And I think the difference is also that a lot of us are in the generation that was taught on paper, right? I remember when I was at school, we didn't have access to computers all the time. We still had to do a lot of the work on the paper. I did some electrical engineering in my undergrad. That was part of it. And you didn't do this. Now students do vibe coding, right? And I think a lot of people in archaeology, they're also guilty of vibe coding. They're not thinking, they're just doing this. And maybe that's a question that I want to pass on to Josh, Christopher, and Jared as well. Have you come across within that context? Because I think it is a topic that's really hot. Have you come across people that do vibe coding where you then find these shortcuts to be, not beneficial?
I think vibe coding, if I understand, you mean like using ChatGPT and things to write code for you based off native language, kind of. Yeah. Yeah, I mean, I know I've done a bit myself. I know other people are doing it. The one thing that I've always struggled with is I'm not a great person with languages, and to me, coding's been always that thing that I've just never been able to pick up, despite my numerous best efforts. So it's always been relying on getting grants to get computer scientists to help me to write the code that I'm after. And when I do manage to do it, I'm usually sitting for a few days to run a code and then have to debug it for a few more days. And that's just simply I don't have time anymore with my current role. So just having come from the international conference as well, talking to people around, a lot of people are using it for the same reasons, and that's just simply to move a bit faster. They've still got, in some cases, computer scientists involved, but they're using the same methods as well to help write their code quicker, which I think is, that's not interesting. But yeah, it's definitely being used to kind of despecialize computer science in some ways, because it really was it still is this entire subfield that every other field's wholly reliant on. And so you're asking archaeologists to become computer scientists, you're asking biologists and everyone else to become computer scientists just to kind of do their original field. And to me, it's kind of democratizing that knowledge a little bit, which I do find useful. But yeah, I quickly have run into issues with it where it's like, yeah, you haven't quite understood what I want, or you add a little bit on, it takes something else off somewhere else, or it messes up the initial results. And I found that it's almost like you're going through a student's graduate work. You're like, you've kind of got the right idea, but you've missed the point, and I need to redo it here. So yes, I've found it useful in that it has allowed me to do more than I could previously on my own. But also, yeah, I've found a lot of problems.
I would say that my experience has been similar in that I don't work with other people's code very often. I'm working on my own stuff. I've attempted some vibe coding from time to time, and it's ended up just driving me crazy because I get into some crazy error loop that it's saying, oh yeah, for sure the solution is this, and it's like, oh that, yeah, and then it just keeps on going and going and going, and eventually I realize it's as confused as I was when I turned to it in the first place, and the easiest path out is to break through whatever the thing I was stuck on. But I see the vibe coding in student work, in people doing literature reviews, even where they're turning to ChatGPT. It's not even a coding thing. It's just a reliance on these as treating large language models as a search engine, as a source of information, for feedback on things. It's very positive in its feedback, and that's where I probably see it more often in other works, where I'm seeing like, I can see you've been led down a sort of rabbit hole here of being reinforced by something that is A, going to tell you this is fantastic, B, going to act like it's got all the answers, but it doesn't, and you've lost track of how to assess whether it's giving you the right the right answers or not. Yeah, is probably where I find it most concerning in my experiences so far. Yeah.
I have to laugh when you were talking about that feedback loop, because I've come across it, and you know, sometimes you just kind of lose your temper and you're like, no, that's not correct. And then it's like, oh, I'm sorry. And then one time out of 20, that actually works. But I don't know who that's serving, but yeah.
All right, I'm going to keep us moving and skip a couple of questions. I wrote too many. All right, I wanted to talk a little bit more about some of the specific limitations we come across working with archaeological data when it comes to machine learning, and maybe some ways you've seen to overcome this in your work. Roger?
I'll just jump in and as I said before in my brief 5-minute intro, abundant intelligence is one of those areas for me where a lot of the biases that we introduce are really Eurocentric biases, especially in indigenous research, First Nations. And I think that is definitely one of the biggest limitations, and we want to be very, very careful in what we're doing here. One, how we're treating the data sovereignty, but also how we interpret the data. I think there's a lot of dangers there.
I think my experience of where we're really limiting what we're doing with machine learning is that in archaeology, we tend to be quite entrenched in what attributes we're collecting in the first place. So like Josh gave some really good examples of different two different lithics analysts in the same room might be measuring different attributes. And once you actually take an object and reduce it down to the attributes you've chosen, a lot of the time the analysis you're capable of doing with machine learning is not actually much better than classical statistics would have been for those attributes. I think that the power of neural networks is that they can actually take many, many more attributes than we're traditionally familiar with actually extracting from archaeological data. But that requires us taking our hands off the wheel in terms of which attributes we're selecting and giving it larger models. So this can be just to unconstrain it to being more of a pattern recognition task without forcing it down the rabbit hole of but we want this in terms of the attributes we've pre-selected. The danger here is, of course, that we lose track of what it is learning and how we can interpret that. But I think that that's still to the strength, because the outcome that we get, we then actually have to interpret what it's produced, and it puts the interpretation challenge back on us. So it removes this kind of here's the analysis, here's the result, here's the conclusion. It's all produced by AI. It's giving us a new perspective of the patterns that it's seen that's significant in this data. Without forcing it down a rabbit hole that we see. I think in rock art and in similar to lithics, we have camps of people who are really dug in about these are the key attributes that are significant. So trying to remove that bias and not go down any one of those camps, I think is been something that I've found successful in determining groupings, and I'm seeing that in ceramics and lithics analysis using ML approaches now. So that's probably one of the key limitations I would think that we apply in archaeology.
I would agree with that. I think, as Robert, you said, we have a Eurocentric view that's coming to these models as well. And Jared, you're saying removing kind of some of our pre-assumptions from the data is a way to go about it. And I agree with that to a point. I think that one of the things that, when we start really thinking about these attributes that we've always applied, whether it be in ceramics or stone artifacts, is when you go back in the literature, why was it called a core, or how was that flake defined? And we actually found in a couple of cases it was what some old French guy said in the 19th century and no one ever questioned it. And that's hugely problematic. Like, it's actually making us question some of the foundations of our discipline, which I guess is interesting in itself. But I think also we need to be careful when we do analyses like that, especially with indigenous data, that we don't remove their agency as we're trying to remove these pre-assumptions as well. And I think that there's a fine line to be walked there, which is it's all in the context, right? I'm but it is just a way. I think it's just another thing that we have to be hyper vigilant of, that in making things very high tech and efficient, and trying to find these patterns that we couldn't otherwise identify, that we're not kind of throwing the baby out with the bathwater.
Do we have anything else to add to that question, Christopher?
Yep. Just more of a general comment. If you're training ML models for doing any form of analysis, models will never be 100% accurate. Even getting 99% accuracy is very rare. And what metrics you use for determining accuracy are also problematic as well. So if you use just standard accuracy, usually that's not representative of the thing that you're actually, the performance feature that you're actually trying to analyze. So if you're applying any form of model for analyzing for data, then you've got to go into it with an expectation of this model is going to be wrong a significant proportion of the time. I need to have provisions in place to be able to catch when that occurs, or have those errors crop up in low value areas where it's not going to matter. That's something that you always need to have in the back of your mind when you're working with these sorts of technologies.
Absolutely. All right, I'm going to quickly move to our last question because I am aware of the time, and I think we have talked a lot about inappropriate uses of machine learning in archaeological research, some of the ethical questions. So I think probably what I just want to end on for this part of the panel is, do you guys have any, maybe a single takeaway each about how we can better regulate this or bring some better practices into our universities or workplaces, even if it's just a small change to kind of, get things in the right place when we use machine learning?
Well, I'll kickstart this and I'll make this really short. So this was my point earlier. Essentially, it's about, I think, systems thinking. There's a way forward here where we teach people that everything that you do has an impact on something else. And that holds true, right, for a lot of these AI applications, as Jared talked earlier, whether they're sandboxed, which means no one outside of your framework has access to this, or they're larger models where you're using corporate systems. But I think systems thinking helps people to understand how the dots connect and be more responsible.
I think that the inappropriate uses would be when we're just wholesale applying it to huge regions with no consideration of whose heritage we're actually looking at. So, in archaeology, looking at remote sensing data to identify sites, there are plenty of archaeological sites that iwi know about that they do not want recorded or on the National Register, or for various reasons. So there's those kinds of concerns. And for regulation, I think it really comes down to a matter of practice, where we need data management plans and agreements with our stakeholders that aren't just contracts, but they're conversations. So they're maintained as living documents, where as data is perhaps there's some kind of central contact agency put on the document, so that as members of boards change 10 years down the line, you need to at least have approached these people or go through the central government to find out who you should approach before you can use this data. And I think these are kinds of regulations that right now really rely on the individuals and the morals of the individual. There's nothing legislative in New Zealand, at least, about doing this. And there's certainly calls to make it legislated, but it's not going to happen anytime soon, I don't think. But it would be good if it did. But yeah, I think there are it's all about informed consent from traditional owners is what we really need to work towards, and realizing that with any data management, it's not a tick box. It's an ongoing negotiation which doesn't stop when you publish. It's a continuing thing that may continue down the line. And we've seen cases recently, I say recently, in the past few years, where people have used secondary data from pre-published sources and had it retracted because they didn't get the traditional owners' permissions to reuse that data. So, this is already happening, and it needs to be, people need to be aware it's happening, and I think it's just a case of good practice, really. And if we have to legislate it to make it good practice, so be it.
Yep. I think there's I suppose on the ethics side of things, there's an interesting parallel in the whole. There's been a lot of talk over the last year in terms of people like mass job losses because of automation of entire industries of jobs, and especially in the software sector. And kind of what we're seeing happen is the chaff parts of the jobs are getting automated away, but the actual essence of the jobs, say the parts that require very structured critical thinking, and even discussions of the tech circles are parts of jobs which are very human and human driven, sort of what's remaining, and these jobs are going to evolve into being orientated around those sort of critical thinking and more human aspects of the jobs. And I think there's a bit of a deliberate choice in that sense, because you can either evolve or you can choose not to evolve, and if you don't evolve, then you get shutted out of the system. So if we look at parallel to ethics, is what we're happening is we're having lots of AI tools rising up, which makes things run faster. And we have a choice of, do we use them to move fast and do a lot more things and move fast, or do we move at the same pace, do the things that we would originally do slow, do those fast, to leverage time to focus on the human things that are actually really important. And I think there's a deliberate choice there that needs to be made. Hopefully we'll make the right choice, but there's a very interesting parity there, and I think we all need to kind of do some deep thinking about what that actually means in how things are going to evolve moving forward.
Absolutely. Jared, do you have any last thoughts on this question?
I think my last thoughts are probably not specifically legislative or regulatory. It's more going back to that this is moving so fast. And by that, I mean that the bar for entry, how easy it is to use machine learning approaches, is becoming less and less. Like for a long time, and by long time, I mean within the last decade, it started out as being you had to code it yourself. Then you had to be able to take someone else's model and fine tune it yourself. And now you can just talk to GPT and you can do all sorts of things, right? And it's just getting easier and easier for people to use machine learning in a broader sense, broader set of ways. I don't really see a rate of change in the way that we're talking about this within education, within our institutions, about how we're actually teaching. I don't think there's many archaeology degrees that it's a compulsory that you learn how to build a machine learning network. But I do think that there's benefits in that, because then you can understand the risks that are associated with it, the ways that it works, all the functionality. And while there might be some legislative changes that would help our current situation, that situation is going to be different in 5 years. It's going to be different in 10 years. But if we can move collectively as archaeologists, in a broad sense, our understanding can keep up with that, we can keep on making continued improvements to that regulation, to that legislation, that are informed, rather than the situation we're in now, where it's moving so far ahead of our understanding of it. It's almost impossible for us to influence regulation, because as soon as we do, something else is going to come along that bypasses that in some capacity or endangers that. That's my perspective on it.
Amazing. All right. Thank you so much, guys. So that's the end of our structured Q&A session.